something like 40% of Africans rely on cassava as a source of calories. And I like to think of it as a famine, like fallback crop, because in times of famine, people can fall back on the cassava to get through those times. And one reason that works is cassava being a root crop, it can stay good in the ground for a couple years. And so certain crops you might have to harvest all at once, but cassava is not like that. You can sort of harvest it as you need it. So there's a number of reasons we might want to improve cassava, and the reason that is what we're looking at in our project currently is that cassava contains cyanide, which is a toxin. And if the cassava isn't processed properly, then when people eat it, the cyanide is released in their body, and especially for people who don't have enough protein in their diets, they can get these different neurological diseases, including they can be paralyzed by this disease called konzo. And that's for people who are eating mainly only cassava for a long period of time, and maybe in the context of not properly processing or incompletely processing it. So the processing can be arduous. It can be that this variety of cassava might need to be soaked in a river for 3 days, or it might need to be dried in the sun, or things that might take time. And maybe if you're starving, you might cut some corners on that. Or maybe if you have a new variety of cassava that you're not familiar with, you might not process it properly. And there are also studies that even when people think they're processing it properly, there's still more cyanide present in like commercial cassava chips and things like that than is allowed, and then people know. And so there's a lot of reasons to want to just remove the cyanide from the cassava. And so that's what we're doing with this project. We've established cassava transformation here at Berkeley, which is not a new thing in the world, but it's new here at Berkeley. And we are performing the CRISPR currently. So the CRISPR editing, there's a couple genes that we're targeting in the plant that we know are required for the cyanide pathway. So when we knock them out, we expect that we'll remove the cyanide from the plants. First, we're starting on cassava varieties that have low, medium, and high levels of cyanide precursor, and then we're going to expand to farmer-preferred varieties, because that's really the point, right? And then our plan is to make the edited plants available to partners around the world for further testing. So we can only test in the greenhouse here, but we have partners who can test in the field in Africa or maybe in the Caribbean. See how the plants do. There's a hypothesis that the cyanide might help ward off pests. So you really need to test that in the field. Well, just in general, CRISPR is a really great tool to use with cassava because there are many different varieties of cassava that are propagated clonally. So what that means is rather than doing crosses, people take a stake from the plant, they cut the plant up into these stakes, and then they plant it, and then they know they're going to get another plant with the same traits that they like. And for CRISPR, that allows us to change just one gene or one trait very precisely and not disturb the other traits about the crop that people like. And so it's really the precision and the ease of use that makes CRISPR a great tool.